Welcome to solverfy.
In this question, we have this situation. So we have a slotted link, pin at O, and then there's a peg P, goes along the spiral guide. The guide has a equation R equals to 0.4 theta. We want to determine the velocity and acceleration of the particle when the peg leaves the slot. Okay, and this R is the length of this thing is 0.5 meters. Okay, and we are also given that the angular velocity theta dot is 3 radians per second and is constant. Okay, so this means that the theta double dot angular acceleration is 0. Okay, so since we are given the r versus r as a function of theta, okay, so we can do time derivatives. Okay, we have r dot equals to 0.4 theta dot, and r double dot equals to 0.4 theta double dot. Okay, and we have theta dot equals to 3 radians per second, and theta double dot is equal to 0. Okay, and so at r equals to 0.5 meters, theta is r divided by 0.4. So 0.5 divided by 0.4, you get 1.25 radians. So, and then r dot is 0.4 times 3, and this is 1.2 meters per second. Okay, so for the velocity part, okay, we are going to find the radial component. This is r dot, so 1.2 meters per second. And then the v theta is r theta dot. Okay, so r is 0.5, theta dot is 3, and you get 1.5 meters per second. And so the magnitude of velocity is equal to vr squared plus v theta square root. Okay, 1.2 square plus 1.5 square root, and you get 1.92 meters per second. Okay, so here are the components and the magnitude. Okay, and then for the acceleration, okay, we have radial components, which is r double dot minus r theta dot square. Okay, so since theta double dot is 0, so r double dot is also 0. Okay, 0 minus 0.5 times 3 square, and you get negative 4.50 meters per second square. And then a theta is r theta double dot plus 2r dot theta dot. So 0 plus 2 times 1.20 times 3, and you get 7.20 meters per second square. And then the magnitude of acceleration is equal to ar squared plus a theta square root. This is equal to 4.5 square plus 7.2 square root, and you get 8.49 meters per second square. Okay, so this is the magnitude, and these here are the components of acceleration. Okay, and that's all for this question.